Let's look into the discriminant. What's the discriminant? It lies in the quadratic formula under the square root b squared minus 4ac. And what this does is it tells us that how many times a curve intersects with a line, be it the x-axis or any other line. So this is one case and this is the other. So the discriminant tells us how many times these two lines interact. So here you can see they interact two times, here it interacts 0 times, and here it interacts 1 time. So these are a few cases that we'll be looking into through a few examples, and the values a, b, c are derived from the quadratic equation, and this is the quadratic formula. Alright, so these are the three questions. Let's look into them one by one. So the discriminant we have is b squared minus 4ac. This is going to be constant for all equations, and we're going to be inputting the values into this equation. So here we have a, b, and c. I'm going to be taking the sign as well. So minus 10 squared minus 4, and minus 9. 10 squared gives us 100, and this gives us 144. So this gives us 244. So we can see that b squared minus 4ac for this equation is equals to 244. In other words, I can say that b squared minus 4ac is greater than 0. So 244 is greater than 0. So b squared minus 4ac is greater than 0, as 244 is greater than 0. So when the discriminant is greater than 0, it means that the curve and the line intersect at 2 points. Yeah, so there are two real and distinct roots, two real and different roots. Now let's look at the second question. Here we have our ABC. Once again, the discriminant is going to be the same. Input the values, and you're gonna get 144 again. So here in this case, the discriminant is equal to 0. And when the discriminant is equal to 0, it means that there are two real roots which are the same. In the first case, we saw that when it was greater than 0, the roots were real and different, but here the roots are real and same. So in this case, we can say that since the two roots are real and same, there is essentially only one root, and that the line acts as a tangent to the curve. Oops. So this is a visual representation of this case over here. Right, now let's look at the third equation. So here we have our ABC. Discriminant is going to be the same. Input the values, take the sign as well. And this gives us 200. So solving this, gives us minus 136, and in this case our discriminant is less than 0, as minus 136 is less than 0. And when our discriminant is less than 0, we say that we have no real roots and that there are complex roots, which we'll look into later. But essentially what this means is is that the line and the curve do not meet. There is no point of intersection between the curve or the line. Alright, now before we go into the notes of these, there's one thing that I'd like to clarify, and that is the initial equation before applying the discriminant. So what we're given with is this. So if you're given this initially and this y is equal to 0, then this means that this is the equation of the curve only. And when you apply the discriminant using the quadratic formula using this equation, what you get are the x-intercepts of the curve. So when applying discriminant, you get x-intercepts. So when you apply the discriminant rule on this equation, when your initial equation is equal to 0, you get the x-intercepts. And what I mean by this is that this is the curve and this is the x-axis, and these are the x-intercepts. And it's not necessary that you're gonna get two intercepts. As you've seen previously, you can get either 1, 2, or none at all. But this is one case. The other case lies when your initial equation isn't equal to 0, and you have another equation of a line equating to it, and then you bring it to the previous equation we have seen by taking this to the left hand side, equating it to 0, and so on. So at first glance, this equation number 2 and equation number 1 may be the same, but they actually aren't, because you're actually equating the equation of the curve and the equation of the line, and then you're bringing it to this form. So when you apply the discriminant on this equation now, what you're gonna get is not the x-intercepts, but you're gonna get the x-coordinates of the points of intersection between the curve and the line. So what happens is that you get the x-intercept is that you get the x-coordinates of these points right here. And as I've stated previously, it's not necessary that there are going to be 2 points. It can also be one, as a line can act as a tangent, or it could be neither uh, as such. Alright, so these are the two cases that I was talking about, and let me just separate these. Wait, let me write it down. So this is the distinction between the initial equations before applying the quadratic formula to get the discriminant. And as stated previously, the discriminant helps you to determine how many times a line, which can either be the x-axis or another line having the equation of a line, and how many times that line and the curve meet. Okay, so this is case 1. Case 2, let me move this down. Initial equations. Okay, so now that we're done with these cases and the initial equations, let's move on to the notes. So when the discriminant is greater than 0, we know that there are two real and distinct roots, meaning two real and different roots, and that the line and curve intersect at 2 points. Now in this case, the line can either be the x-axis or the line having having the equation of a line. And in b square minus 4ac, when that is equal to 0, there are two real and equal roots, meaning essentially one real root, and that the line acts as a tangent or curve. The line can also be the x-axis depending on the initial equation. If b square minus 4ac is equal to 0, that means that those two do not interact, and there is essentially no point of intersection, hence no x coordinate of point of intersection and no real root. And when b square minus 4ac is greater than or equal to 0, this is a special case. It means that there are real roots, and we don't define whether there are 2 points or 1 point of intersection, but we do know that there are either 2 points of intersection or only 1 point of intersection between the line and the curve. So an important thing to note here is that when the discriminant is greater than 0 and when it's greater than equal to 0, these two things do not mean the same thing, and that they're essentially different things. And here both cases apply. It can either be that the line is a tangent to the curve, or it intersects properly at 2 points to the curve. So yeah, let me just bring this up. And let me highlight something. Key notes. Alright, so this was it for the discriminant. I'm going to be solving a few questions in the next video, and till then you can revise everything you need from here.